The next topic is stability of coordination compounds. Now, stability of coordination compounds can be expressed in terms of stability constant or formation constant. And the stability constant or formation constant is the equilibrium constant for the formation of the complex from the metal and the ligand. And that is, if we write the equilibrium representing the formation of the complex from the metal and the ligand, the equilibrium constant of that equilibrium is called formation constant. For example, a very simplified way of writing the formation of the complex MLN, and this is formed from the metal M and N number of ligands. So a very simple way, M plus NL gives MLN. And in this, since the complex formed is stable, we know concentration of the metal ion and the ligands in this equilibrium will be very less. And that is, dissociation of reverse reaction will not be taking place to a large extent, or equilibrium will be lying far towards right. That depends on the stability of the complex. Now the equilibrium constant K, here stability constant or formation constant is represented by beta. So here beta N number of ligands here. So beta N is equal to concentration of the complex divided by product of concentration of the reactants M and ligands. N ligand, concentration of ligand raised to N. Normal way of writing the equilibrium constant. Product of concentration of product divided by product of concentration of the reactant, with each term raised to the coefficient as power. So this is the formation constant for this equilibrium, which represents the formation of the complex from the metal ion and the ligand. Now if we consider a ligand with complex with 4 ligands, we can write the equation M plus 4L giving ML4. So this is the net reaction. Now this formation can be considered as taking place in 4 steps, or we can split this equilibrium into 4 steps, where in the first step M is combining with 1 ligand to form ML. And then ML is combining with L to form ML2. So this is ML1 actually. So ML2. That ML2 is combining with one more ligand to form ML3. And finally ML3 plus L gives ML4. Actually this complex formation is taking place in the aqueous solution, where water normally forms a complex with the metal ion, and when we add a strong ligand, that ligand will displace water molecules from the complex one by one, and that is how the ligand complex is formed. Now here we are not representing the water molecules here, directly ligand to simplify the equation. So we have 4 steps showing the formation of the complex ML4. For each one, the stepwise stability constant, this K1, K2, K3 and K4 are called stepwise stability constants, which are the corresponding equilibrium constants for each step. K1, concentration of ML divided by concentration of M into concentration of L. Then K2 is concentration of ML2 divided by product of concentration of ML and L. This way we can write all the 4 stepwise stability constants. And if you look at, you will find the relationship between the stability constants, stepwise stability constants, and the overall stability constant beta n, and here it is beta 4 is equal to K1 into K2 into K3 into K4. This from the equilibrium. If you multiply all these equations, you will get the net equation beta 4 is equal to mL4 divided by m into L raised to 4, and that is the overall stability constant is the product of the stepwise stability constants. This already you have seen in the lesson equilibrium. When an equilibrium is split into different steps, then the overall equilibrium constant is the product of the stepwise equilibrium constants. Same thing here also. So beta 4 is equal to K1 into K2 into K3 into K4. And here again, from the value of this, if this complex is stable, it won't be dissociating to give the constituent ions, and that means this concentration will be large. So if higher the concentration of the complex, higher the value of the stability constants. So stability constant, and therefore higher the value of the stability constant, more is the stability or higher is the stability of the complex. Reciprocal of this stability constant is called instability constant or dissociation constant, and that is 1 by beta n. For n number of ligands, 1 by beta n is called instability constant or dissociation constant. And this, of course, the value of this will give an idea about the stability also. Just like a stability constant, this also, how easily the complex will dissociate to give ions, and that is called instability or dissociation constant. And then again, stepwise stability constants values, in most cases we will find the value of stepwise stability constant decreases. That is K2 will be less than K1, K3 will be less than K2, and K4 will be less than K3 in most of the cases. So these are a few points regarding the stability. Of course, stability depends on the charge on the metal ion. Higher the charge, normally higher the charge, more is the stability, and also nature of the ligands. Strong ligands will form more stable complexes than weak ligands.